Hello everyone and welcome back to this online NPTEL course on aquatic geochemistry. This is your 9th lecture and we have already been discussing a bit about the water sampling, the chemistry, the metals and the different types of elements that we are going to analyze in the different types of waters. And in this particular lecture, we are going to understand more about how to sample and different water bodies require different understanding to do the sampling. So we are going to try to see certain new aspects on water sampling techniques. So whenever we are going for water sampling, the type of sampling we are going to do depends on the type of research objective, right? So research objective means, of course, you have already selected whether you are going to sample river, whether you are going to sample lake, whether you are going to sample the ocean or groundwater system, what you are going to work on, of course, that is there. Now, based on that, aquatic system, and the kind of question that you're addressing, whether your question is just a characterization type of question, whether it is a question which is cyclical, has follows a certain type of cycle, is talking in terms of long term processes, links with climate and other parameters. So if you have different questions, different types of studies are done, right? So depending on the type of research question that you're addressing, depending on the your aquatic system, and depending on the logistics, the last important factor is the logistics. How you are going to access the site, how much manpower is available, how much financial support you have got. So all this depends like how well you're going to do and complete the sampling, right? Now based very broadly based on the temporal scale, we have two types of sampling. One is the synoptic sampling and the other is a time series sampling. What is synoptic sampling? It is one time sampling. Okay, so you go to the field, you take one sample or maybe couple of samples from different locations. So that is, you're going only one time, you're not going to go any more in any other time of the year or next year or in future. So this is called synoptic sampling. Okay, so sometimes when we are doing a pilot scale study means we have no understanding of the ground data. So to just have an understanding of the ground data, we take a few samples, we analyze them, and then we see, okay, this is our what I would say, which is the background, and we have to think in terms of these kind of samples. So you make a field visit, you maybe collect a few samples. So those pilot scale studies are often synoptic sampling. Okay, and maybe based on those first initial data sets, you build a very big project. Okay, so which may be multiple years or multiple seasons and all that. So based on these synoptic sampling, a long time series sampling can be thought of in later on. Now generally what happens is when you're doing a very big studies, okay, when your geographical area coverage becomes more, then people preferably do synoptic sampling. That is, we go to the field once, we take the samples, however many samples we want to take, and then we come back and then we do not repeat it any further. Okay, so river sampling, if I'm doing an entire basin, river basin sampling, then it may be having 50 sites. Now to go and visit another time, it may not be possible. So if within a few days, like maybe within 10 days or 15 days, I'm visiting those many sites and I'm collecting waters from all those sites, that is my synoptic sampling. Or if I'm going to an expedition on for oceanic sample collection, generally all these oceanic expeditions and polar expeditions, they are thought of in a very large scale. So there will be a collective group of scientists who will be writing their individual research objectives. They will take the expedition which will follow a particular route, and they will visit all those locations. They will collect the sample once and they will return back. Doing the same trip over and over again, it is never feasible. Okay, so oceanic expeditions, polar expeditions mostly are of synoptic type. As compared to that, time series sampling is of different nature. It is collecting the samples very frequently. Now, how frequently depends again on the research objective. What you're trying to see, daily data set, you're trying to check weekly, you're trying to see something which is seasonal. So depends on what you want to do, depends on the research objective. All natural systems, specifically water systems, aquatic systems, they have a certain pattern, right? A certain kind of seasonal pattern, day and night diurnal patterns are also there. So therefore, we go for time series sampling, right? Now, time series sampling, as I said, can be of different resolutions. It can be daily resolution, it can be weekly resolution. So you basically fix the resolution, whether you come to take a sample every day, you can decrease it to per hour also, you can sit there, you can take a sample every hour. So that becomes, however, suits your research objective and suits your logistics. Okay. So the resolution is highly variable, dependent on, it can be from few minutes to months, and the repeativity of collection, of taking the sample at every repeated interval, is what we call maintaining a series. Okay, so that is the time series sampling. Okay, and generally such sampling requires a lot of manpower, a lot of logistics. It is generally funded through national programs or international programs, where you have a good support to continue to be able to do that for a long period of time. Now, among both of them, there is no recommendation as such. It is thought of what is the need. So if you are going for a river study, if you are going for groundwater study, if you are going for a lake water study, which is in as compared to more inaccessible sites like the oceans or the polar sites, it is more preferable to do time series sampling. Again, depends on the logistics, depends on the feasibility of where you are, whether it is possible for you to do it every time or not. Now, different methods have been created, right? So we'll talk about this in more details, right? So this was based on the temporal scale. So either you collect only one time or you can do a time series sampling. Now, where you are going to sample? So the spatial scale. Okay. Now, based again on the spatial scales, there will be different types. So first is single location. So you select a very critical site. A critical site means, again, related to your research objective. You can select a particular site which is you think is a very pristine site or is a control site, as you can say. So you can have a pristine control site, and you can have another site which is very stressed, which a lot of activities, anthropogenic activities going on, or any kind of geographic changes is happening, or an area which is subjected to a lot of climate change impact. So there can be different rationale behind selection of sites, right? So if you are taking single sites, or couple of sites, or 3 sites, 4 sites, and you're doing the sampling continuously in those few sites for a very long period of time. Sometimes it can be for 30 years, 40 years data sets people have done. So doing repeatedly in one location gives you an idea of how the aquatic system at that particular location is changing with everything. Either it is changing with the climate, or either it is changing with the land use, land cover stressors. So how, what is changing? You can have, very in-depth studies if you are sampling at a particular location. And in the lecture where we were talking about future visions and critical zone observatory, which develops greater in-depth understanding of the aquatic systems, such single location observatory is of prime importance, because those observatories give us very long historical data sets. There are it can go for 50 years, 100 years, and extremely these data sets are extremely valuable because they are so less in number, these critical zone observatories all over the world. Now it is slowly growing, and I think in many have come up in India as well. But all over the world, if you see, as compared to the number of aquatic bodies, aquatic lakes, rivers, the number, as compared to the number of observatories are extremely low. Basin scale sampling is, again, you sample across the scale. So when you're trying to understand contaminant transport, when you're trying to understand how in-stream processes are happening, how different spatial locations, how they are having similar chemistries, or how similar kind of stressors, maybe anthropogenic stressors, maybe any kind of climatic stressors, how they are impacting in a similar way, you can do a basin wide sampling. So here you see there is a watershed. Okay, so we have discussed what is a watershed in our second lecture, I believe. So this is the river. Okay, now across this river we are going to take sampling sites. So we are going to begin location. Our location, first location will be somewhere where the river actually starts. So the source of the stream. So from there, however it is accessible, you take the samples and you start collecting samples as we move down the stream. So this is basically just an example to show how we start the sampling from the source of a river to the to the mouth of the river at near the estuary or near the delta, wherever the river is joining the ocean. So groundwater also same thing, since we cannot see the groundwater aquifer from the top, we go and sample as and where the boreholes are, as and where the groundwater pumps are. So we follow that, we follow the aquifer map if we have or one aquifer map, or we maybe need to be creating one aquifer map. So you follow the aquifer map, and therefore you can take the sample accordingly. And here is a ocean sampling. This is a path that is showing. So based on the ocean currents, sometimes when these ODPs is ocean drilling programs, these are very specialized programs, and now they do all kinds of scientific work. Initially they used to collect samples from the bottom of the ocean floor, and a lot of analysis used to be done, different research purposes, research objective. Now a lot is going on related to understanding the geochemistry, understanding the elemental cycles. I would not say now in terms of now meeting today, but it is in terms of maybe last 30 years. A lot of programs, international programs are happening, and the reason these are all international programs is because, as you can see, these oceans doing such an ocean, such a huge journey is not possible for all the scientists, right? So some nodal agency will be there, and they will ask scientists from all around the world to join their ocean drilling program. Based, again, they will be selective, there will be selection processes. So based on the selection, a few will be allowed to go and do the research there, right? So they will generally take few months to go through all the locations that has been plotted here. Every year there can be, it can be different. Certain locations they visit every in a frequency, at a regular interval, maybe in a 6 months or on a yearly basis. And certain sites they can just go maybe only once, like a synoptic sampling. And this again, locations is based on many different parameters. It can be based on, so the research objectives that is put forward, based on that they select how many stops they can make, right? So some will be very close to the some current meeting, some will be far from where the currents are meeting, or there may be some other processes are happening, and a lot of parameters are thought of where they can do the sampling, because they have to go through the path, right? So it has to be feasible. Now sample collection, now we have talked about temporal, we have talked about spatial scale. Now let's talk about the vertical scale, right? Now when we are taking a sample, say suppose you have an aquatic body, where are you taking the water from? Okay, are you going to take the water from the surface? Are you going to go to the bottom of the channel, there you are going to take a sample? So again, all of this depends on your research objective. If your research objective is such that you are looking at mostly dissolved samples, dissolved geochemistry, then I think a water sample which is collected just below the surface, maybe not too deep, okay, as much as possible, not disturbing the, not just taking just from the surface water and the atmosphere layer, that is a boundary. So from that boundary you take a little deep, maybe 20 centimeter, 30 centimeter deep, from there you take a water, because dissolved chemistry is generally found to be pretty homogeneous in turbulent water, okay. So if the water is turbulent, just like in rivers, I would not say lakes, but certain places wherever there is turbulence, you can take a one-time sampling from the surface water, and it can give you a representative sample of the dissolved geochemical data. Now if the river, or if suppose if you are taking a lake, or if you are taking samples from groundwater, then what do you do? Now groundwater is a different thing altogether, because there you cannot see the aquifer, right? So you do not have a concept of taking across the depth. So wherever there is a pump, you are pumping, and that is the water. So but in other systems like lake, where you have a stagnant water body, and lakes can get stratified, right? So due to the stratification, we need to take water from the different depths, okay. Since there is no dynamic mixing happening all the time, then that creates that layers, that stratification, and different processes might be happening that gives it different signatures to the water. Now this becomes more prominent in deeper lakes, okay, deeper lakes, and where there is a lot of organic matter in those lakes, where the bottom sediments are, there a lot of redox related processes can be happening, which is giving the dissolved data will look very different from what is at the surface water. It can be looking very different. So when you are having that kind of a system, it is extremely preferable that you take sample from different depths. Okay. Same thing for rivers also, which are very broad, which are very what I would say, sluggish flows are there, where a lot of meandering is happening. So people have taken samples from the left bank of the river, people have taken samples from the right bank of the river, and there they have seen differences in the water chemistry. So for that reason, we always recommend that for river sampling, you take depth integrated samples. That is, you take samples at different depths and you mix it. So it is then called a composite sample. Okay, if that is feasible, you please try and do it, because kindly understand that if you're taking a sample at a depth of 5 meter, 6 meter, there is a flow. You're trying to collect water from a flowing water body. It sometimes becomes difficult to pull up. You cannot definitely do it with hands. You need to use a pulley system, as you can see in this sampling system. It uses two types of sampler. Okay, this is called a fish sampler. So what happens is you put it, you let it go inside the stream at a particular depth. Say you mark it at 3 meters or at 5 meters depth, or whatever is your known depth that you want to go, and at that particular depth you press the lever and then this opens, right? Then the water flows in, okay, and again you push the lever and this closes, right? As soon as it closes, this water no longer interacts with the rest of the water, and when you pull out, that is the water that was flowing through at that particular depth. Same thing for this. You put this also inside you at a particular depth, you lowered it, say 10 meter depth, 6 meter depth. So you lower the sampler and you collect the water. So this gets closed, this gets closed, and whatever was flowing at that particular time gets trapped, and then you pull it up and take the water out. Okay. Now, why do we do surface water and different kind of depth? Now, if you're looking at sediment geochemistry, depth sampling is extremely important. Why? Because you see, when a river is flowing, what the river is carrying, that is the sediments, depends on its velocity, right? So the carrying capacity of sediments with the flow depends on the velocity of the river. Now the velocity of the river varies with depth. Okay, so with where the surface water is there and the atmosphere is there, so at the surface water and the air interface, there is a friction. Okay, there will be a wind flowing, so there will be wind related friction and all. So that causes a slight lowering of the velocity at the top of the water. Same thing with the bottom also. When the water is flowing, the friction with the ground, okay, the friction with the bedrock slows it down near to the bottom of the river. Bottom of the river meaning where there is the water and the bedrock interface. So water again gets slightly, velocity of the water slows down near to the bottom. So therefore, the highest maximum velocity is somewhere near the middle of the depth. Okay, so in rivers, the depth of the stream also varies with the hydrograph, right? So there will be certain months of the year where the volume of the river, where the depth of the river will be high, certain months where the depth of the river will be low. So you have to know what is the depth of the river at that particular time, and depending on that time, how many depths you should be collecting. So all this should be thought of. Now again, as I was saying, so the flow velocity is different. Now what happens when the flow velocity is different? Different sized particles are carried at different depths. Okay. Now understand, so there is a clay size fraction, there is a sand size fraction, there is a silt size fraction, there are small pebbles, cobbles, okay, large boulders. So different size of sediments are getting carried at different depths, and depending on these size fraction, the minerals are also getting segregated, right. So the minerals which is having a very plate like structure, very flaky, they are very light, they have plate like structure. If you have seen mica, if you have seen any kind of biotite, if you have seen any of those kind of minerals, you will understand those minerals are mostly very light and flaky. They will be moving in the clay fraction, in the in the finer with the finer fraction of the sediments. So they will be flowing in the top surface of the water, as compared to more heavy minerals. Okay, more heavy the mineral is, they will be settled more towards of the bottom of the channel. So there is a natural segregation of different types of minerals along the depth axis. So therefore, if you are doing a sedimentological analysis, it is extremely important that you collect samples from different depths. Okay, so there is first, if if you are sampling for dissolved, it is okay if you take a grab sample. If you are taking sediment samples, then it is okay, you go for depth wise sampling. And then also you have to keep in mind that there is a left bank concept, there is a right bank concept. So you can take a composite sample. So you take sample from the left bank also, you take sample from the right bank also, and you mix it. If possible, you can you can take treat them as separate samples, or you can mix it and you say that that is your composite sample. Okay, so this composite sample, you can now take a measurement. Again, same thing, if you are having taken water from 2 different depths or 3 different depths, okay, maybe near to the sample, near to the surface, or somewhere near to the half depth, or however much you can reach with your logistical support, however much you can reach into the stream or into the lake. If you are mixing both the water and you create a composite sample. Okay, so that is how manned samples are happening. Now what about if there is a unmanned station? So as I have shown you in this previous slide, there are certain critical zone observatories. Now in critical zone observatories, something like this is created, and this is called a river lab. What is it? It is an extremely sophisticated enclosure, where you have some automated systems like this that will collect the water, as you can see here. So there will be a pump kind of system which will be collecting the water. It will be entering the lab here, and through an automatic system, the water will be filtered and collected in different bottles. The filtration can happen there itself, or sometimes it can just collect the unfiltered water, or whatever you are trying to measure, it will just collect the water. But how this is important is that using these kind of unmanned system, automatic systems, you can collect water at a very high frequency, and you can leave it for a few days, come back, you remove this tray, okay, put more new bottles, and then you can again leave it for another few days. So if you are taking water in a daily basis, so every day you need not visit, you have a automatic station that will collect the water for you, and you can so again depends whether it is filtered water, unfiltered water, and the important aspect of this is that here the collection takes place at very regular intervals, and therefore you can have the sampling for a very long period of time. Okay, so here there is no opportunity of collecting it depth wise or whatever. It is wherever that pump is, fitted. So at that particular depth, every time the water is getting collected at a regular set interval, and you are having your time series data. Now, selecting a sample site, as I have already mentioned, for rivers, it is river chemistry, how it is varying. If you are trying to understand the different sources, the different tributaries, what you are giving importance, depending on your research objective, you are going to select the sampling site. Okay, generally what we are doing is we are following the Y pattern of sample selection. So I have shown here, this is an example of map of, this is river Ganga, where it is starting from Gomukh, and then it is flowing through different locations. So this is Gangotri, Harshil, these are the different locations, and different tributaries, as and where they are joining, you collect a sample, right? So we follow what is called the Y pattern of samplings. For example, you have a stream joining here. So say suppose you are taking a sample here at Chamoli, right? So you collect the sample water from here, then another tributary joins in. So you collect the sample just before this tributary joins the river. Okay, so you collect the sample here, then again it mixes up, and after a certain location downstream, you collect the sample again from the main channel. So therefore what is happening, you are creating a Y. So this one and this one. Again it mixes with another tributary, you take the tributary sample, okay, you already have this sample, again after mixing you collect another sample. So this is what is called the Y way of taking samples. In mountain streams there is no left bank, right bank concept. It is extremely turbulent. Wherever it is possible to safely collect water, that it is collected. Now, why it is changing? Why is there we find a spatial pattern in our data? There can be a lot of reasons. It can be due to the bedrock, due to change in the how the rocks are changing in the entire catchment. That can be with locations it is changing. What is the source of water? In the mountain regions, there can be more glacier meltwater, snow meltwater as compared to rainwater and groundwater. Now you come down to the plains, there will be more groundwater input, there will be more rainfall. So the sources like groundwater, rainwater, their contributions to the river is changing across the spatial scale, right? So therefore certain chemical changes are also seen in the data set. Weathering changes are there. In estuaries, a lot of other processes are happening. So if you are sampling here, a whole lot of processes are acting. We will look more in details when we are talking about brackish water processes and all. Contributions from land mass via air and groundwater. Now wherever there is stresses, like the groundwater is getting polluted there, then whenever the river is passing through a city where the air is polluted, right? So there a lot of other chemicals, pollutants are getting added. So that is again human disturbance, direct disturbance, like creation of dams, creation of bridges, urban centers. Then if the water is getting extracted at a particular place, or rather sewage is getting discharged into the river. So all these factors come in when you are deciding at what spatial scale you are going to collect the samples. Okay, whether you are going to collect here, whether there is a city here, whether you need to collect the water after the city, before and after the city. So whether there is changes in the bedrock, whether you should collect water from that zone, whether there is a dam, so before and after a dam. So all these parameters you need to think of before you go for a sampling, and this is specifically extremely important for rivers because of all the of all the processes that is related to so many parameters that can alter the river chemistry. Now with this I come to the end of this particular lecture. We are going to discuss more about sampling techniques and instrumentation in our next lecture. Thank you.